Hello students. Yesterday we have covered oxidation of alcohol by KMnO4 in dilute sulfuric acid. Mechanisms we have understood. Now it's a time to use k2cr2o7 potassium dichromate. Topic is not involved in 12th level. It's for JEE Advanced and B.Sc. Let's check what is the mechanism behind 1 degree alcohol oxidation by k2cr2o7 in acidic medium. First, we need to understand k2cr2o7. This is the bonding over here. The negative charge of two oxygens are balanced by potassiums. Potassium dichromate. Ionic compound it is. Potassium and dichromate ion is making ionic bond. Now, it is very surprising that actual oxidation is not done by K2Cr2O7 in acidic medium. Actually, what is happening when we are using dilute H2SO4, that dilute H2SO4 we know that it contains water molecule which always break like H positive and OH negative, and H positive ion particles are also there from acidic side. So what is happening here? Like this is a OH negative wants positive particle for the attack, chromium. Check, chromium is surrounded by 6 electrons, 1, 2, 3, 4, 5, 6 electrons which are getting shared with oxygen, and as we know oxygen is highly electronegative, so all these 6 electrons are going toward oxygen side. That's why this chromium atom is carrying partial +6 charge. Now due to this +6 charge, it has a tendency to attract negative particle, which it is doing. After this, what will happen? From here, the bond will break, due to which this oxygen particle will become negative because it is getting extra electron, which will be satisfied by H positive particle. So here we will have a generation of two new particles. First I am writing this one. This oxygen as it is negative charge. Here we will have OH. Same condition from this side. This OH I am going to join here. Double bonded oxygen and this negative oxygen. Because OH was attacking with electrons, so obviously when bond will break, electrons will go toward oxygen because electrons are coming from OH side. Secondly, oxygen is more electronegative than chromium. So here the transfer of electron will be like this. These two new particles are generated. Due to H positive ions, we will have an attack on these O negative ions, due to which these particles will transfer into this one. Two particles of this. Now what is this? This is chromic acid, which will bring oxidation of 1 degree alcohol. Means actual oxidizing agent over here is chromic acid. Dichromate particle will just get hydrolyzed in this condition, and chromium bond will break and they will produce two particles of chromic acid. Now that chromic acid will do further oxidation. Please check carefully how you have to break this. Chromium is partially +6, that's why negative particle will be there, OH negative, which will attack on it, due to which bond breakage will start And obviously electrons will shift toward oxygen, which will be attacked by H positive particle. So these two particles will generate. Here two oxygen negatives are there, which will be balanced by two H positive particles, which are coming from sulfuric acid side. And we will have two new particles of chromic acid. Now what this chromic acid will do, let's check. This is the first step that you need to understand. The role of k2cr2o7 will create chromic acid. Now 1 degree alcohol I am using in this case. Suppose, and the general formula of 1 degree alcohol is this. Let's use it. Very easy mechanism. Now chromic acid, one particle of chromic acid I am using, that I am writing like this. Only one particle is required. Two were generated, only one is required for the oxidation of this 1 degree alcohol. This is 1 degree alcohol. OH is connected to carbon, which is further directly connected with a single carbon. So this is 1 degree alcohol. Out of alcohol and chromic acid is more acidic. So what it will do? It will provide H positive particles for alcohol. And when H positive particles will release out, obviously these electrons will shift toward oxygen. Listen very carefully. When I am not writing electrons on oxygen, make them by yourself. Like always on doubly bonded oxygen, we will have two pairs. So if I am not writing, make them by yourself. From here, H positive particle will generate out. This is an electrophile. What it required? Electrons. Who can provide electrons? Here we have electrons. Oxygen of alcohol. Now we know what will happen. When the third bond of oxygen will generate, it will be a dative bond, due to which this oxygen will carry now a positive charge. This hydrogen is carrying vacant orbital. For the bond formation, 2 electrons are required, which will be donated by this oxygen. Out of these 2 electrons, 1 electron it will completely transfer toward hydrogen. That's why it is carrying +1 charge. And 1 it will keep with itself. In this condition, we know what will happen. Unstable will start breaking bond from carbon. So here we will have a generation of carbocation. And let's check here what we got. Because this oxygen will break bond from hydrogen, so here we will have 3 pairs and a negative charge, because 1 extra electron of hydrogen it is taking. Now this oxygen negative and the carbocation that will generate, they will combine with each other. And here we will have a release out of H2O. When they will combine together, what they will create? Let's check. The oxygen's negative charge will finish, because this one pair it will use to make bond with carbon. That's why 1 electron that was extra will completely transfer toward carbon. A dative bond will generate, because here vacant orbital is going to be generated. And Cr as it is, OH as it is, and this oxygen as it is. Now this intermediate which is generated over here, it is known as chromate ester. Chromate ester. Check carefully. That's it. This is the role of chromic acid here. Chromic acid is going to deliver H positive, which will release out water molecules from alcohol, due to which the carbon of alcohol will become positive charge, carbocation. Vacant orbital will generate, which will be satisfied by the negative charge of the oxygen of the chromic acid, due to which chromate ester will generate. Now, in this chromate ester, you can check around chromium, oxygen, 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 and this side also oxygen is there. So this whole group is becoming strong electron attracting group. Same like in the case of KMNO4 we have manganate ester. Same here we have chromate ester. Same work. Due to which, because it is a strong electron pulling group, so these electrons of the carbon will go strongly toward oxygen, due to which this carbon will start attracting electrons from hydrogen side strongly, and these hydrogens will become highly acidic in nature. Lot of positive charge will generate on them. Please check. This chromate ester which was generated, and this group, because of lot of oxygen atom, it is strong electron attracting group, due to which electrons of carbon are going toward this side, due to which this carbon will become strong positive particle, and due to that positive charge it will start attracting electrons from hydrogen side. That's why hydrogens will become highly positive. We can call them acidic hydrogen. This is the main role of chromate ester. Now let's check what will happen. After this, two possibilities are there. We know these hydrogens are highly acidic. So number one, first possibility. In dilute H2SO4, as you know, water particles are there which can provide H positive and OH negative. Working as base, this is OH negative working as a base, it has a tendency to attack on this H positive. So this attack is possible, due to which what will happen? Bond between carbon and hydrogen will break. This one. And obviously these bonds, these electrons will get shifted toward oxygen side like this for the bond formation, because this part is electron attracting part, and oxygen is stable with two bonds. So if this bond is going to be generated over here, this bond will break, and obviously due to repulsion, because these electrons are coming here, these electrons will be repelled and they will go to chromium side. Bond will break and we will have a generation of this. What is this? Aldehyde. And here we will have a release out of this particle. In this particle, you can check chromium oxidation state. Right now, what was the oxidation state? 6 electrons it was sharing, 1, 2, 3, 4, 5, 6 with oxygen, and all these 6 electrons were going toward oxygen. That's why it was carrying +6 charge. After bond breakage, you can check one extra electron, this one has gone toward chromium, so its oxidation state will be reduced to +5. So here we have a generation of aldehyde. This is the mechanism. This is the first possibility that I have told you, which we call, this is intermolecular proton transfer, because another particle, another molecule is attacking on the proton. This we call intermolecular proton transfer. And second possibility, let me tell you, which can happen over here. Let's rub it. So we will have a space there. Second possibility, because we know these hydrogens are highly acidic, these hydrogens. One more possibility is there, which we call intramolecular proton transfer. Means in a same molecule there will be a transfer of proton. Yes, oxygen. These oxygens which are connected with chromium, we know due to higher electronegativity, they are strongly negative. This is strongly positive. So between them, interaction can be there. So this hydrogen can be attracted by this oxygen. And obviously oxygen will break bond from chromium and will shift electrons toward itself for the bond formation of hydrogen. And these electrons will go toward carbon side, which it will use to make bond with oxygen. So obviously what will happen? Bonds will break like this. After this breakage, you can check what you will get. Number one, this particle. When carbon is going to make going to shift these electrons with oxygen. So between carbon and oxygen, double bond will generate. Aldehyde again. Here, what will generate? Chromium, as it is this oxygen, OH as it is, one extra electron from oxygen side, and here OH will generate this one. Here you can check oxidation state. 1, 2, 3, 4. Let's check. 1, 2, 3, 4. 6 were there, plus 6. 1, it has got extra, so plus 5. It is now in plus 5 oxidation state, like this. So this is intramolecular proton transfer. In a same molecule, proton is getting transferred. In this fashion, two ways are there in which 1 degree alcohol can make aldehyde. Now next, can k2cr2o7 further oxidize aldehyde? Yes. Aldehydes which are generated over here will react with water molecules like they were reacting in the case of KMnO4, due to which water we know H positive, OH negative. This H positive will attack on oxygen because oxygen is carrying partial negative charge. This OH negative will attack on carbon. Pi electrons will shift toward oxygen. With the help of these pi electrons, it will make bond with H, which have a vacant orbital, and a vacant orbital of carbon will be satisfied by OH, in which oxygen is carrying 3 lone pairs. With the help of these 3 lone pairs, out of these 3 lone pairs, 1 lone pair it will use to satisfy vacant orbital of carbon. And here we will have a generation of this. In previous mechanisms also we have discussed this. This we call hydrated aldehyde. And this aldehyde and this hydrated aldehyde will be in the stage of equilibrium. Now when these hydrated aldehydes will further react with the chromic acid, so that equilibrium will shift in forward direction. Means as they will finish, new hydrated aldehydes will generate, due to which all the aldehydes particles will get oxidized. Let's start the oxidation of this particle. Very easy mechanism. Chromic acid again. Same. It is more acidic as compared to this diol. So what it will release out? H positive. Oxygen will break bond from its hydrogen. That H positive, this H positive is looking for electron. Who can provide electron? Oxygen. Due to which oxygen will become unstable and will break bond from carbon. When oxygen will break bond from carbon, electrons will go toward oxygen because oxygen is more electronegative, due to which on carbon positive charge will generate with a vacant orbital. That vacant orbital will be satisfied by this oxygen, which is getting extra electron. So in a same diagram, I am going to combine them. So please watch carefully. This OH as it is. This H I am writing here. This oxygen which is going to make a dative bond with the carbon, that I am writing here. Rest part as it is. And what will release out? H2O will release out. That's it. What we got again? This is again chromate ester. This chromate ester will make this hydrogen highly acidic, because this part which is joined with the carbon is strong electron attracting group, due to which these electrons are getting shifted toward oxygen side. In turns, the carbon is attracting electrons from hydrogen side strongly. That's why this hydrogen is getting high positive charge. That's why it is acidic in nature. Now what will happen with that? Same which was happened with 1 degree alcohol. Now again you have two options. Number one, intermolecular proton transfer. Means water molecules will provide OH negatives. They will attack on this acidic hydrogen, due to which bond breakage will be there, and that bond will be shifted by carbon toward this oxygen, because this part is electron attracting part, due to which second bond will generate between oxygen and carbon. That's why oxygen will, for stability, it will break bond from chromium, and that electrons will shift toward chromium, because these electrons are coming here, they will repel these electrons, due to which, please focus on this part, what we will get, RCOHO. Which functional group it is? Carboxylic acid. With the release of H positive, OH negative, H2O. From here, this will release out, in which chromium have what oxidation state? +5. So intermolecular proton transfer will happen like this. Intramolecular, try by yourself. In that intramolecular, you just need to shift this positively charged hydrogen on this negatively charged oxygen. Already we have discussed, try by yourself. Same carboxylic acid will generate. Now, can carboxylic acids further oxidized by k2cr2o7? Please check. In carboxylic acids, we don't have hydrogen on this carbon. This is the main problem. In alcohols, like I am writing RCH2, this is 1 degree alcohol. In aldehydes, which were converted to hydrates, this, check this. Here we have hydrogen with this carbon. Here we have two hydrogens with this carbon. That's why that mechanism is possible. But look at carboxylic acid. In carboxylic acid, such hydrogen is not available. That's why carboxylic acids cannot be oxidized by k2cr2o7. Even by same reason, they can't be oxidized by KMnO4, because KMnO4 is also following same mechanism. But if your carboxylic acid contains one carbon like this, and here we have hydrogen, always it will get oxidized by KMnO4 as well by k2cr2o7, because now we have hydrogen. Same mechanism you can apply. What mechanism? Chromic acid. Which will release out H2O, due to which there will be the generation of chromate ester, due to which electrons will transfer strongly toward this part. That's why carbon will attract electrons from this hydrogen strongly, and this hydrogen will become highly positive, means acidic, which can be released out from the molecule either by intermolecular proton transfer or by intramolecular proton transfer. After that, this carbon will shift this bond here, and between oxygen and chromium bond will break. Check out this. What will release out? CO2 gas. That's why I am saying, whenever you are getting methanoic acid, means carboxylic acid of one carbon, you have to convert it to CO2. That's it. This is the end of the video, where we have understood 1 degree alcohol oxidation by k2cr2o7 up to carboxylic state with mechanism. Thank you very much for watching the video.